Okay, today we're going to be using the quotient rule for derivatives, and we're going to be proving it using first principles, so you guys can grasp the understanding. So we're going to start with let f at x equal f at x g at x, and recall that the formula for f prime at x is limit as h tends to 0, f at x plus h minus f at x over h. Okay, so now that we have these, we're going to do this. F prime at x, and then we sub in our numbers, and we will get this. Fx plus h, gx plus h, minus f at x, g at x over h. What we're going to do here is, let me write the limit sign, is h tends to 0. We're going to do cross multiplication, or lowest common multiple, for this part here. So we're going to do fx plus h, g at x. It's kind of like cross multiplying g over gx plus h, g at x. And then with this h, we're going to do the reciprocal, so it's going to be times 1 over h. And then what we want to do from here is kind of switch the denominators here, which we can do since it's multiplication. So we're going to do, I'm forgetting to write the limit sign. So as limit h tends to 0, ooh, that's messy, let's fix that. As the limit h tends to 0, f at x plus h, g at x minus gx plus h, f at x, and then we're going to do over h, and then using the properties of limits, we're going to do limit h tends to 0, and then switch the denominator, so it's 1 over gx plus h, g at x. Okay, so now that we've got to this step, we just continue using algebra. So what we're going to do here is something that you guys should not know or figure out yourself, because that's what math theory is for. So from here we're going to add and subtract f at x and g at x, just like this. And the reason we can do this is because this equals 1 no matter what we do, or equals 0, sorry. So that's why we're allowed to actually do this. It doesn't change the actual question. So this is what we're going to do, and then we're going to group together fx plus h, g at x, minus f at x, g at x, and then we're going to factor out a negative here. So negative, and then gx plus h, f at x, and then this turns into a minus, becomes a minus. So it's going to be minus f at x, g at x, over here, like this, over h as the limit continues here on the here. This will be important later. Okay, so let's continue moving on. So just keep going with the algebra. This is simple factoring now. So we got, or let's split them up actually. G at x minus f at x, g at x over h minus, let's add another, let's use properties of limits again. To this minus sign will be going here, by the way. Let's use properties of limits again to do the same thing. So limit as h tends to 0, gx plus h, f at x minus f at x, g at x for h, times limit tends to h tends to 0, 1 over gx plus h, g at x. And then we're going to continue once again. Now it's going to get to factoring, and we're going to also have to use the properties of limits, same thing we've been doing up to now. So limit h tends to 0. We can factor out from here, we can factor out g of x. So then we also write another limit sign, minus f at x over h. And just before I move on, we can see that this resembles this, which is what we wanted in the end, and you'll see how they relate together. Then we're from here we can factor out f at x. So limit as h tends to 0, f at x, and then write the limit sign again. Again, this is similar to this, but instead it'd be g prime at x, not f prime at x. And then we continue with our limit here. Limit as h tends to 0, 1 over g at x plus h, g at x. Okay, from here, the limit as h tends to 0 of g at x, since there are no h's, it just becomes g at x. Nothing happens. And then this, we can recall, and goes to this. So we just simply put f prime at x minus limit of f at x, which there are no h's, so automatically just becomes f at x, and then same for here. So it becomes g prime at x times 1 over, let's make sure we understand. So this 0 goes to here, so it becomes gx plus 0 g at x. G at x times g at x, which equals g at x squared, which you guys will understand how that connects to the quotient rule, unless you guys already know it. So 1 over g at x squared. And then simple combinations. You get g at x, f prime at x, minus f at x, g prime at x equals g at x squared. And this is the quotient rule right here, proved and ready for you guys to understand. So this might be a bit messy and a bit confusing to understand, as I'm trying to make the videos quick and fast-paced. I don't want to spend too long just proving this, but you guys can see. So I would recommend taking a couple watches and understanding and kind of not memorizing, other than the only part that you do have to memorize is this step here. This step is crucial to memorize here, because that's something that you can't just come up with or theorize. This has been theory, and it's difficult for just high school students to figure this out in calculus. But the rest of it you guys should understand. Use the properties of limits, which you should have been taught before you even get onto derivatives and proofs. And make sure you understand this in case you get this on a test or an exam. It's crucial, so just make sure you read it over, understand how I proved it, and I will be doing the sum rule, the product rule, the chain rule, and I'll be moving on to the exponent rule too, or the power law. Thank you.